In this session, we will perform the design exploration studies. Please open the DNA design exploration. The problem definition is as follows. We have a cylinder which looks like this. The radius of the cylinder is 9 mm and the height of the cylinder is 21 mm. So on this cylinder, we will perform an FEM analysis whose boundary conditions are like this, where the bottom surface is fixed in all degrees of freedom, and on the top surface of the cylinder, a force of 450 newtons is applied in the x direction. And once the FEM analysis is performed, we will extract the stress from this, which is the maximum bond masses stress induced in the cylinder because of the boundary conditions. And once we have performed the FEM analysis, we will make use of this stress and the parameters of the cylinder for the design exploration studies. So here is the design exploration. First, we will start with parameter study. To find out the components related to parameter study, please navigate to Control tab, and here we can see all the parameters. So first we will start with the parameter setup, which is this one. Now we have to link up all the parameters and the response to this parameter setup. So let's go to stress response and right click on the component and say link to parameter setup 1. And similarly, we will do it for the radius and also the height of the cylinder. Now we can go to the parameter setup, and here we can see the parameters are linked here. So these are the minimum and the maximum bounds of these parameters. One can also change the values of this by simply editing here, which can be like this. So once this parameter study is set up, now we will perform the design exploration by using the component design exploration here. And then in the design exploration, here we will define the number of experiments to be performed. By using this, we can define the number of experiments. Let's say we would like to perform 10 experiments, and the sampling is carried out using Latin hypercube sampling because of the fact that it creates sample points in an optimal way. So we can select OK, and here we have seen that all these designs are generated, and now we have to evaluate these designs. One can also change the parameter value of any of these designs by simply entering this editing mode here like this. And here we can evaluate all the designs now. We can see that all the designs have been evaluated now. So here we can sort the responses by just clicking on the name here, and it sorts in the ascending order of these values. So here we can see that this design has the lowest stress value. This is not the global optimum value, but it's a local optimum of all the experiments that we have performed. So we can adapt this design by simply applying this design here, and this parameters will be applied to the design. In this case, we have seen a simple example in order to understand the principle and working of design exploration. One can also apply this to a complex cases where different experiments have to be performed for a parametric design. We can also see the sampling points created by Latin hypercube sampling with this workflow here. So we can use these designs and then deconstruct the designs, and here we can use the parameter values, which are radius and the heights, and then we can use this construct point in order to use the x coordinate for one of these parameters and y coordinate for the other. And we can blend in this one, and we can see these are the sampling points that have been generated by Latin hypercube sampling. This is not the standard workflow for visualizing the sample points, but for the moment this can be used to look at the points. In the next session, we will move to the sensitivity analysis and parametric optimization.